So let's see how you guys did on these problems. We talked about this one in the last video. Let's see how you guys did in this one. I know that each measure of this side is s cubed. We know that the whole thing is 27 feet cubed. To go backwards and solve for the length of one side, we're going to take the cubed root. That means these guys cancel. That means these guys cancel. And the cubed root of 27 is 3. So using our question, the length of one side, one edge of the crate is 3 feet. We've got a square patio that, this will show, is 196 square feet. And if we take the cubed root, we know that the edges, each side of the patio, is 14 feet. So this one should have been relatively straightforward. C equals plus or minus 2, because we're dealing with taking the square root of each side. This symbol indicates take the square root. People refer to it when they're just talking about it, reading a number, is radical. That's how we refer to it, not the square root symbol. It's called a radical. Now, when you are taking, you've got a cubed, the inverse is taking the cubed root. Whatever you do to one side, you have to do to the other. Now, some people write down their cubes. 1, 2 cubed is 8, 3 cubed is 27, and we are good to go because these guys cancel, and the cubed root of 27 is 3. Sign matters with cubed roots, and if your answer is positive, your cubed root is positive. If your answer is negative, your cubed root is negative because it's an odd number. So the only root that works for 27 is a positive 3. Did this one stump you? Because if we're taking the square root and solving it, we're going to take the square root of this side and the square root of this side. If I think of my neighbor square roots, I know that the square root of 64 works out evenly and is 8. And the square root of 81 works out evenly, and the answer is 9. But 80 is neither of those. So how do we figure it out? Well, there's 2 ways. We're going to simplify the radical in the first way, And we're going to estimate the radical in the second way. So we're going to figure out if there are parts of 80 that can be square rooted, have perfect square factor pairs. So if I'm thinking of perfect squares, I'm thinking of 1, 4, 9 to see if any of those work with 80. Right away, I know that 80 is 4 times 20. And I'm taking the square root of 4 times 20. Now, I can't take the square root of all of it, but I can take the square root of the 4, which is 2. And now there's only a 20 left under the radical. I could factor pair 20 again and get 4 times 5. And this time again, I'm going to take the 4 out and find the square root of it. These are all multiplying factors, so everything's multiplication as this is working. And now I have 4 radical 5 is how you would describe this. It is an equation, so it could be a plus or minus radical 5, 4 radical 5. Now, estimating is when we are determining a decimal equivalent. We're getting close, we don't have it exactly. But I know that it's somewhere between 8 and 9. And since 80 is really close to 81, we're going to be almost at 9 with 8.9. So your estimate would be plus or minus 8.9. You have to look at your problem to determine what it's asking for. So if I go to Desmos and I put in the square root of 80, I can see my answer is 8.94427. So I am really close with my 8.9. When we were figuring out the square root of 60 earlier, we said 7.7. 80, let's go square root of 64. So I want you to find it out based on your estimate and your simplified radical. Put radical, and I'm going to put this side as estimate. Press pause and see how you guys do. So let's do it. Let's take the square root of both sides. My first step is factor pairs. I want to break this up into factor pairs. I am looking at factor pairs with 4, 9, or 16. Those are the first non-1 numbers with perfect squares. Well, the only one that works with 24 is 4, because 4 times 6 is 24. And I can pull out the 4 and take the square root of the 4 and get 2. 6 stays. 6's factor pairs are 2 and 3, and they don't have any perfect squares. Neither one works. So in simplest radical form, plus or minus 2 radical 6. Now, if I have an estimate, the perfect square below it is 16, because the square root of 16 is 4. The perfect square above it is 25, and the square root of 25 is 5. 24 is down here really close to 25, so my guess is going to be 4.9. My answer has to be somewhere between 4 and 5. Just like 24 is in between 25 and 16. So my estimate answer is 4.9. Now checking with our calculator, let's get this going. Let's get this to be 24, 4.89, which rounds to 4.9. So that's kind of cool. Go ahead and pause and try this one. Remember, you're going to do it based on simplifying the radical, and we're going to do it based on estimate. All right, let's see how you guys did. If I have x squared equals 60, and I'm going to take the square root of it and break them up into factor pairs, I'm looking again for 1, 4, 9, 16. The only one that I can see working is 4. I know that 60 is 2 times 30, but that would mean it's 4 times 15. And I'm going to bring out the square root of 4 is 2. So my simplified radical term is plus or minus 2 radical 15. My estimated term well, I know the square root of 49 is 7. I know the square root of 64 is 8. So I'm going to estimate the square root of 60, probably like more than 7.5, so maybe like 7.7, 7.6. And most of the time, you can tell from your estimated answers. And if you had a multiple choice where you would have plus or minus 7, plus or minus 7.5, plus or minus 7.7, and plus or minus 8. I would go for the 7.7. That's what I would choose. Now, if we look back here, let's go back to this problem, and the square root of 60, 7.7. 7.7 is where I would have gone. Now this one is cubes. So we're going to be dealing with this as x cubed equals 24. And then here, We're going to do it as the radical cubed root side, and we're going to do the estimate side. So if I'm looking at, let's see if I can move this over. If I'm looking at this problem, to get rid of a cube, you take a cubed root, which just looks like a square root, but instead it's got a 3. And whatever you do to one side, you do to the other. These guys cancel. Cube roots only have one root, they don't have 2. And I'm thinking of factor pairs of 24. And this time, instead of looking for perfect square factors like 4 times 6, I'm looking for perfect cubed factors. That would be 1 times 24 and nothing would change. 6 is not a perfect cube, but 8 is. And it's 8 times 3. So with me factor pairing 24 as 8 times 3, I can bring the 8 out front and take the cubed root of the 8 and get 2. And so I can write this in a simplified radical form to cubed root of 3. My estimated forms, when we take the cubed root, I know that 27 is my next perfect cube. That's 3. And I know that 8 is the previous cubic root, and that's 2. So the cubed root of 24 fits somewhere right in between. Halfway between 27 and 8, it's probably right around 17, and that would be 2.5. Since 24 is so much closer to 3, I would bet this is 2.8. You will these mean almost or an estimate. Now if I go back to my calculator, 2.8 cubed root, let's talk about how you enter it. So when you're entering a perfect cube, you click the in root, cubed root, radical. The 3 goes there, and then you arrow under, and you get 24. And that's 2.8, 2.9, which is what we got. This one has a lot of parts, and I want to make sure you write this one up to submit so I can grade it, and then we'll go back through it.